Okay, so hopefully we should be up and running. Today we're going to get started on chapter 2 in your textbook. It's all about linear functions and equations. Some of this is going to be review from stuff we've talked about last week, last 2 weeks. Some of it will be review from other classes, and some of it is going to be new. We'll talk about the test today in class for a little bit, assuming that everybody's turned it in by then. I'm still waiting on a couple of people. But hopefully we'll get that going. So we're going to start with chapter 2.1. This will be a two-part video, and then we'll get into some other stuff on Wednesday. So forms for equations of lines. We've already looked at slope-intercept form. Slope-intercept form is probably the one that you're most familiar with and is the most common. We've also already looked a bit at what linear functions are and what they represent. We know that graphs of linear functions appear as straight lines, or at least we should know. We know that linear functions are defined by a constant rate of change known as the slope, which is often simplified as m, or represented by m. We also know that the equation of a line can be written as f of x equals mx plus b, or y equals mx plus b. The equation f of x equals mx plus b, or y equals mx plus b, is called slope-intercept form. So obviously the slope is m, and then b is your y-intercept, which is what y is equal to when x is 0. There are other ways to write equations of linear functions. The one we're going to look at the most is called point-slope form, and it carries this general formula. So this looks a little bit more complicated than slope-intercept form, because you've got this, well, where's my pen not working? There it is. Okay. So you got this x1 and this y1. This just means you need the slope, and then you need any one point. So like, let's say we have a point of 2, 3, right? This goes in for x, and this goes in for y. You'll notice that if x1 is 0, so if you're looking at the y-intercept, which has 0 something, right? Then this is going to be equal to b, and when you simplify this, it'll be mx plus b. So like, if that's the y-intercept, you'll get the same thing. So if you simplify the equation, so when let's say you have a slope of 2 and an x value of 1 and a y value of 3, when you simplify this, it'd be 2x minus 2 plus 3, which would be 2x minus 1. When you simplify that down, you also get it in slope-intercept form. But we'll talk about that a little bit more in a minute. So let's see how we determine point-slope form. First, for the first example, we want to find the equation of a line that passes through the points -2, -3, and 1, 3. And then we want to write our answer in point-slope form. So first, we need to calculate our slope, and we do that the same way we would do it normally with a slope-intercept form. So m equals y2 minus y1 over x2 minus x1. Last time I did tell you that you want to use the point furthest to the right for y2 and x2. It doesn't technically matter, because if you do use the point further to the left, then both your top sign and your bottom sign are going to be flipped, which means you're going to end up getting the negatives, or whichever signs that you accidentally flip are going to get evened out either way. But it is almost always easier if you use this point that's further to the right. So whichever has a bigger x value is the one you generally want to use. But anyway, in this case, we've got 3, which is our y for y2, minus -3, which is our y1, and we've got 1 minus -2, x2 minus x1. That simplifies to 6 over 3, which is equal to 2. So now that we know our slope, here's our equation, or here's our problem again. We know our slope is 2, and we want to write it in this form right here. So our 2 is going to go in for m. That's easy. And then we can pick either point to represent these x1 and these xy, or x1 and y1, sorry. Yeah, so in this case, we're going to use 1, 3. And so that looks like this. We get y equals 2, x minus 1 plus 3. And this is our final answer in point-slope form. This is done. So if you're asked for point-slope form, this is as far as you have to go. You'll notice that the 1 is from here, and the 3 is from here. They're color-coded and stuff. If we had wanted to use this -2, -3 point, then it would have been y equals 2x And then it's going to be minus -2, which we can simplify to +2. And then we've got plus y1, which is -3, plus a negative number is minus, so we have -3. These are the same. These are both correct answers for point slope form for this equation. Now, converting from point slope form to slope intercept form, I talked about that a little bit earlier. You may have noticed that this equation can be easily simplified. So we want to distribute this 2. So we got 2x and we've got -2. So we'd get, here, let me break it down, I guess. So y would equal 2x minus 2 plus 3, and 3 minus 2 is 1, so we get y equals 2x plus 1. This is a formula for the exact same line. If you plug in any point for x into either of these, you're going to get the same value for y. So like if I plug in 0, I have y equals 2 times 0, which is 0, plus 1, that's 1. In this case, I have y equals 2 times 0 minus 1, that's -1. So -2 plus 3, 3 minus 2 is 1. So we'd get the same value when we plug in x, whatever the x is. So let's switch gears a little bit. We're going to talk about intercepts. So the y-intercept obviously is part of your y equals mx plus b. Y-intercept right here, that's b when you have a linear equation. But there are also x-intercepts, and these are other things that we're going to be concerned about, especially when we get into nonlinear graphs. We're going to be really concerned about the number of x-intercepts, especially for looking at increasing and decreasing intervals, but we'll talk about that more probably in a couple weeks. We've talked a lot about b already, that's that y-intercept. But the y-intercept b is the point at which the graph hits the y-axis. So you're intercepting the y, right? Like, should make relatively simple conceptual sense. The x-intercept on the opposite, or by the same token, I guess, is the point at which the line intersects the x-axis. So x and y intercepts collectively are known as just intercepts. So sometimes you might be asked to calculate the intercepts of a line. They'd be asking for both the x and the y. Calculating the y-intercepts when you have a function is pretty easy. Since a y-intercept is the point at which a function hits the y-axis, and the y-axis exists at x equals 0, all we have to do is plug in 0 for x to solve our equation for y. So for instance, if we have the function f of x equals 3x plus 7, and we want to solve for the y-intercept, all we have to do here is plug in a 0 for this x. So we'd say f of 0 equals 3 times 0 plus 7. 3 times 0 is 0, which means that we have 0 plus 7 equals f of 0, and that equals 7. So f of 0 equals 7. And we can just replace this with y. So if we want to know what the y coordinate is, 3, but this gives us a point, right? Because there's x, y. Oops, I don't know why I said 3, 7. So our point is 0, 7. So yeah, hopefully that makes relative sense. Calculating x-intercepts are a little bit more difficult, but not really that bad. You just have to solve the equation for x instead, and you plug in y equals 0. So in this case, this could also say f of x. Doesn't really matter. We have y equals 2x plus 8. So all we're going to do is plug in 0 for here, or this time. And you can do the same thing for f of x if you want. So what you could do is say, if f of x was 2x plus 8, you'd just say 0 equals 2x plus 8. It really doesn't make a difference in this case. So we have 0 equals 2x plus 8. We subtract 8 from both sides. 2x equals -8, so x equals -4. So that's the x point at which we intercept the x-axis. The actual point is going to be -4, 0, because our y value had to be 0. Okay. So now we're going to talk about a couple different types of lines. Specifically, we're going to talk about horizontal, vertical, perpendicular, and parallel lines. Horizontal lines are easy. Horizontal lines, yeah, like it says right there, are easy to model as functions. The output, the y value, is always the same no matter what the x input is, right? So in this case, we've got x equals what? -1, -2, oops, -3. So the y value, sorry, equals -3 at any given point, right? When x is -4, it looks like y is -3. When x is 0, y is -3. When x is 4, y is -3. So no matter what x is, y is going to be the same thing. So horizontal lines have the general equation y equals b, which is just a constant, any number. So in this case, we have y equals -3, and that's this line right here. If we had a line that went through here, -1.5, we just y equals -1.5. If we wanted this one, it'd be y equals 2. But the point is, it's whatever number that line is at, you just have a y equals. Similarly, vertical lines. One thing to remember about vertical lines is that they are never functions. Remember, the function has one unique y value for every possible x value. In this case, we have one x value, it's 3, but if we have x equals 3, y could be anything, right? It can be -4, it can be -2, it can be +3, it can be anything on this line. So vertical lines are not a function. But vertical lines can be mathematically described by the formula x equals n, where n is any real number. So again, same thing. In this case, we have x equals 3. If we wanted to draw the line here, that'd be x equals -1. We could go, pretty much wherever you want. You can do a fraction, you can do 1.5. It doesn't really matter. But the point is, for a vertical line, you're going to have x equals whatever number that line is on. So yeah, this graph shows the line x equals 3. So to calculate horizontal and vertical lines, we can calculate the horizontal and vertical lines that pass through any given point really, really easily. So if we look at the point 3, 6, so let's say we had a graph like this. Point 3, 6 would be somewhere like in here, assuming that we had like this 5. This is 5. And so we'd want a vertical line that goes through that point and a horizontal line that goes through that point. And it's pretty simple. All you do is, let's see, oh, that's probably getting in the way now. We know that the horizontal line passing through 3, 6 must have a y value of 6. So the horizontal line is y equals 6, right? This is our y. At any point in time on this horizontal line, we need y to equal 6. The horizontal line is given by this function. So it's pretty simple. Hopefully from this, you can predict what the vertical line is going to be. That's going to be x equals 3, because we know that it has to go through the x value of 3. So if you graph these two lines, you'd have the vertical line at 3 and then the horizontal line at 6, and they'd hit at the point 3, 6. Now, parallel lines, these are a little bit more difficult than horizontal and vertical. They could have any slope they want. But one of the nice things about parallel lines is they're always going to have the same slope as each other. So for instance, the lines y equals 3x plus 4 and the line y equals 3x minus 12 are parallel. They're just separated by approximately, 16 vertical distance. We can also calculate the parallel line that passes through a specific point if we have a first one. So like, if you're given, actually, let's just look at the example. If we're given a line like this, y equals -2x plus 5, and we want to find the parallel line that passes through the point 4, 3, we can solve for that pretty easily. So first of all, we know that our slope is going to be the same because they're parallel. So we have y equals 2x plus b, right? We don't know what this b is just yet, but we can plug in these points. So 4 is our x, 3 is our y. So we say 3 equals -2 times 4 plus b. That means 3 equals -8 plus b. We add 8 to both sides, and we get 11 equals b. So now we know what our b is, and we just write out our formula like this. Y equals -2x plus 11. And that is our slope-intercept form version of this point. Now, writing the point slope form of this equation would be super easy, right? You already know the slope is the same as this one, -2. So then you do y equals -2x minus x1, which is 4, plus y1, which is 3. And if you wanted to, you could solve all of this and you'd end up getting the same thing. So, if you drag this out, you have -2x plus 8 plus 3, that's -2x plus 11, right? So they're still the same overall. apparently it's going to work through it on the slide. First, we know that the slope of our new line is still -2, so -2x plus b. Then we plug in our point. We get b is equal to 11, and then our new formula. Last thing we're going to talk about today, I think, is perpendicular lines. So perpendicular, for those of you who don't know, that means that they hit at a right angle. So all of these are going to be 90 degrees. Each angle in between these. Whoa, that was bad. But they hit so that they are 100% the opposite direction. So they're going completely. So if you think about, like the x and y axis, these are perpendicular. One's going straight up, one's going straight across. So perpendicular lines intersect such that the angle between them is 90 degrees. One really nice thing about perpendicular lines is they have slopes that multiply to -1. So if you're ever given a line with a specific slope and you want to know what the perpendicular slope is, so like let's say we have -2, the slope of the perpendicular line, which here let's do m because that's what a slope is. So -2, you can plug in this formula, -2 m equals -1. So you can already tell that this is going to be 1/2. But we're going to talk about how to actually do that. So slopes are opposite in sign, plus or minus. So if you have a slope of -3, then the opposite or the perpendicular slope is going to be a positive number. Right? They always have opposite signs. And then they are also fractionally inverse. So if the slope you're given, if you think of it as a over b, then the slope you're going to use is b over a, and you also switch the sign. We'll look at a couple of examples for that. So to determine the slope of a perpendicular line, invert the slope of your first line and give it the opposite symbol. So in this case, let's look at these specific examples. So for a whole number, we want to think of it as 3 over 1. So then we want to flip that, which gives us 1/3. And then this one's positive, so we need to give it the negative sign. So our inverse slope, or our perpendicular slope, is -1/3. Right? All we did is flip this over. We inverted the fraction, and then we gave it a different symbol. So this one, since it's already a fraction, that one's pretty easy. It goes to 3 over 2. And since this one is negative, we know our new one needs to be positive, so the slope is just 3/2. Last one, also a fraction, so we're going to switch that to 7 over 5. And then since this is a positive slope, our new one's going to have a negative slope, which gives us -7/5. And the cool part is you can check each one of these by multiplying it by the original. So we have -1/3 times 3, which is equal to -1. Check. This one we have let's start with our actual slope. So 3/2 times the original, which is -2/3. Cancel, cancel. You get -1. Check. And then this one, same deal. We've got -7 over 5 times 5 over 7. Cancel, cancel, and we get -1. So that's how you can calculate those and how you can double check to make sure you have the right slope. So let's run through one example problem of perpendicular line. So we want to find the slope-intercept form of the line perpendicular to, well, that's weird that it's like that. Y equals -2/3 x plus 2, passing through the slope or the point -2, 1. So first we want to calculate our slope. We invert, we give it the opposite symbol. So in this case, we're going to have +3/2. So M1, this is the one we're given. In this case, this is the one we solved for. So 3/2. Then we plug in our point -2, 1. Let me rewrite this. So now we plug in our point -2, 1. So we have 1 equals 3 over 2 times -2 plus b. 3 over 2 times -2 is equal to -3. So 1 equals -3 plus b. We add -3 to both sides, or we subtract -3 from both sides. So add 3 to both sides, I guess, and we get b equals 4. So then we have to write out our formula, which is y equals 3/2 x plus 4. I believe that is it for today. Yep, that is all. So we can talk about this stuff more in class, especially if you have any questions. You're going to notice that on your assignment today, you've got a bunch of problems that are listed as optional and then a smaller set that's listed as required. The required ones, definitely try to go through, do on your own, see what you can do with those. If you have time and you want the extra practice, I do recommend the recommended ones. It's kind of the point of them, but your grade is only going to be based on the actual required questions. Please come to class ready if you have any questions with this stuff, so we can talk about it. And yeah, I'll see you guys later.